How's it going, guys, and welcome back to Next Gen Vision. Today we're going to look at creating a smart contract of a decentralized voting system. So our smart contract is going to allow us to upload a candidate, and then we can have different accounts vote for whichever candidate they want, and then at the end of it we can see who has the most number of votes and therefore who is the winning candidate. So we're going to write our smart contract on Remix. Remix is this really cool online IDE that actually connects to an Ethereum node so that you can upload directly onto the blockchain. All right, let's get into it. All right, so this is the front page of the Remix online IDE. So on the left, we've got our file explorer, and then we've got the search for files, and then we've got our Solidity compiler. So the Solidity compiler is responsible for compiling the human readable code into bytecode. So then here are the different versions that you have. And then we've got the deploy and run transactions. So this is where you choose where you want to upload your smart contract. So you can either do like injected provider, so MetaMask. So this would allow you to upload your smart contract directly onto either a testnet or the actual Ethereum mainnet. And then you can also choose like a virtual machine. Then you can choose which account you're going to connect to. You can put in details about the gas fees that you pay. So gas fees are transaction fees. And then, yeah, here you can interact with the deployed contracts. So we'll start off in our file explorer. We will create a new project folder. We'll say it is election. And then the template will be blank. All right, so let's create that. So we'll start off by creating a new file. We'll call it election.sol. So you end off with .sol so that the PC knows it's a Solidity file. All right. So the first thing we need to do when creating a smart contract is you need to write the license under which you're deploying your smart contract as well as the Solidity version. So for the license, you'll say --spdx license identifier, and then that'll be MIT. So that's an open source, meaning anyone can use it. And then for the Solidity version, we'll go to the compiler over here on the left, and we'll see that the latest version is 0.8.26. So we'll use that. So you write pragma Solidity and then 0.8.26. All right, cool. So we'll start off by defining our contract. So we'll say contract and we'll call it election. And then let's be more specific, actually, we'll call it US election in honor of the US elections that's coming up. All right. Now there's a few types of variables that we need to define. So the first one is we need every single one of our candidates to have the same structure. Meaning we need a candidate name, we need a description, and then we need the number of votes that they have. So we're going to do this in a structure. So you define struct, and then you say candidate. So that'll be the name of the structure. And then that structure needs to have a name. Oh, we have to define the type first. So the name will be a string, so letters and words, and that'll be name. Then it needs to have a description, so it'll be string description. And then lastly, it needs to have the vote count. So that'll be an integer or unsigned integer, so uint 256, and then vote count. So the reason for defining each of the variable types here is that Solidity requires you to write the type of variable you're defining. So it'll be string, string, and a number. All right, so the next thing we need to do is actually be able to choose from a candidate from the candidate structure, right? So we'll have multiple candidates. So let's say the first will be Trump and the second will be Biden. So the first structure of candidate will refer to Trump and the second one will be Biden, right? So we need a way of pointing towards them. So we're going to do this with a mapping. Now, a mapping is similar to a dictionary in Python in which you've got key value pairs. So we'll say mapping, and then it will be a uint which points to a candidate, right? So a number will point to the candidate structure. And then we'll make this public and we'll call it candidates. All right. The next thing we need to do is have a way of keeping track of who has voted and who has not voted. So we're going to do this with another mapping in which we'll have an address which points to either true or false. So when someone has voted, we will mark their address as true in this mapping, and then we won't let them vote again. So we'll say mapping and then address. And then an address will point to a Boolean. And then this will also be public, and we will call it has voted. All right, perfect. So lastly, we need to keep track of how many candidates we have. So we're going to say uint 256, and then this will just be public and candidate count. All right. We'll keep track of how many there are as we add them. All right, so next we're going to write the constructor function for the smart contract. So the constructor function is a function that just runs once and only once once you deploy the smart contract. So you say constructor, and then this will only set the initial candidate count to 0, right? So candidate count is equal to 0, and that's the only function of our constructor function. All right, so now that we've got the basics out of the way, let's write our first function. Now, our first function is going to be adding a new candidate to our candidates list, right? So we're going to need two things from our candidate. We need them to give a name and a description, right? So we'll say function, and then this will be add candidate. And then the inputs here will be a string memory, and it'll be the underscore name, as well as string memory and underscore description. And this function will also be public. All right. So when someone calls this function, the first thing that we need to do is increment the candidate count, right? So when someone calls this function, it means another candidate is being added to the list. So we'll say candidate count and then just plus plus. All right. The next thing that we need to do is actually add the candidate to one of the candidate structures, right? So add them to the mapping which points to a candidate. So we'll say candidates, and then this candidate's ID will be the candidate count, because every single time we add a new candidate, we're incrementing the candidate count number, right? So this serves as a unique identifier. So this candidate's ID will be candidate count. So we first set it to 0, and then the first candidate that adds will increment the candidate count. So the first candidate will be candidate 1. When the second person calls the function, then it'll get incremented again, so that'll be candidate 2, and then that'll be the second candidate. All right, and then this is equal to the candidate. So candidate structure up here. And then we need to add these details here, right? So the name, description, and the vote count. So the name will be the underscore name that they give in. The description will be the description which they give in. And then lastly, the vote count over here will be set to 0 when we start off. So vote count is 0. All right, perfect. So why don't we go ahead and actually run this function, so compile the smart contract and deploy it and make sure that adding candidates works. All right, so we'll go to the compiler, we'll compile. We've got the green tick, so no issues there. And then we can use this account. We're just going to upload to the virtual machine. So we can click deploy. All right, so we've got the green tick, so it deployed successfully. And then down here, you can actually interact with the smart contract. So if we open it up, we can firstly check the candidate count. It's currently 0. So let's go ahead and add a candidate. So the name and description are the inputs required. So the name will be Trump, and then description will be I am unkillable. This is in honor of the fact that he was almost assassinated yesterday, but was not killed. All right, so let's transact. Cool, it went through. Let's see if our candidate count incremented. It did, so we have one candidate, and then if we go to candidates and put 1, so the ID, then we should get back the information. So string, the name is Trump, the description is I'm unkillable, and the current votes are 0. All right, so that works as expected. So let's delete this. Now, the next thing we need to do is actually add a function for someone to vote for a new candidate, right? So, all right, so we'll say function and then vote. Now, as an input, we need to know who they want to vote for, right? So every single candidate has got a unique ID. So we need them to give us that ID that of the candidate they want to vote for. So that'll be a uint 256, and that'll be the underscore candidate ID. Let's make this small. All right. This function will also be public. All right. So what we need is for this function to have a require statement, right? So we need to check a few conditions before we let someone vote. So the first thing we need to check is that they haven't voted yet, right? And then the second thing we need to do is check that the candidate ID that they're voting for actually exists. So for the first one, we'll say require, and then not has voted of the message.sender. All right, so what are we doing here? So we're going to check this address, so the person calling the function. We're going to check that they are not in this list over here, right? So they're not true for has voted, meaning they haven't voted. And if they are true for has voted, then we're going to leave a message and say, soz, you can only vote one time. All right, perfect. Oh, I see that I just made a mistake here. I need to add that in over here. That is what was giving us the error with the vote. Okay, perfect. Now, the next require statement we need to make is to check that the candidate they're voting for is actually a valid candidate. So we'll say require, and then the underscore candidate ID. Now that needs to be greater than 0, right? And then it also needs to be less than or equal to the candidate count. So if we've added 3 candidates, they can't vote for candidate number 4, right? So then the underscore candidate ID must be less than or equal to the candidate count. All right, perfect. All right, so let's go ahead and add or increment the candidates vote count, right? So we're going to say the candidates, so to access their structure of underscore candidate ID, all right? And now the vote count of that, so dot vote count, must be incremented by 1. All right. The next thing we need to do is actually add the person who has voted, or the account that has voted, into the has voted section. So we'll say has voted, and then the message.sender, and then this will be now equal to true. Okay, perfect. So now we've added the function to add a candidate and to vote for a candidate. The next thing we need to do is actually add a function to call the winner of the election, right? So it'll be the function of getting winner. So we'll say function get winner. This function will have no input. However, it will return the name and the votes of the person who won, right? So we'll say public view returns. So by saying public is obviously that anyone can call the function, and by saying view, it means this function doesn't change the state of the blockchain. So no variables in the blockchain change. All we're doing is getting a value from the blockchain. All right, and then this is going to return a string memory of the winner name and the vote count, right? So uint 256 and total votes. All right, so the only check that we need to do before calling this function is that we at least have one candidate, right? So we're going to say require, and then the candidate count must be greater than or equal to or greater than 0, right? And then the message, if it's not true, we'll leave behind is you cannot vote for a candidate if no one is a candidate. All right, cool. Oh, this is candidate count, my bad. All right. So how are we going to go about calling or finding the winner? What we need to do is we need to go through every single one of the candidates. We need to find out who has got the highest vote count, and then the account or the candidate corresponding to the highest vote count becomes the winner. So we're going to do this in a for loop, right? So we're going to go through every single candidate and then make note of who has the highest vote count, and then that'll be the winner. So let's define two variables. So the first will be a uint 256 of highest votes. All right. And then the second will be a uint 256 of winning ID, right? So the ID of the candidate who has the highest. All right, so let's start our for loop. So we're going to say for, and then the uint 256, I is equal to 1. So in our first iteration, I will equal 1. And then I must be less than or equal to the candidate count. All right. And then I++. So what we're doing is we're going to start with I equals 1. We're going to do whatever is in the for loop. And then once we're done, we're going to increment I to 2. We're going to check that it's less than or equal to the candidate count. And then as soon as we'll repeat this process until we get to the candidate count, right? And then it'll stop. All right, so let's do our if statement. So we want to check now if the votes, so the vote count of that candidate is greater than the highest votes. And then if it is, then this candidate will become the winning ID, right? And then we'll do that through every single candidate until we get to the end. So we'll say if candidates of I, so as we increment through, dot vote count is greater than the winning votes or the highest votes, then we want the winning votes, highest votes to equal the candidates of that ID, their vote count, right? And then the winning ID will equal to I. Okay, perfect. So we'll increment through every single candidate, and then we will do the if statement. We'll check that the candidate's vote count is greater than the highest votes, and then if it is, then that candidate will become the winning ID. All right. So now the winner name that we need to return by the end of all of this will be equal to the candidates of the winning ID dot name, and then the winning or the total votes will be equal to the candidates of the winning ID and their dot vote count. All right. Cool. So everything looks good. We don't have any errors. And that'll return to there, and this will return to there. All right. Why don't we go ahead and compile and check this out and make sure it works. So let's compile. All right, green tick. Then we can go ahead and deploy the smart contract. All right. Now let's start off by adding a candidate, right? So the first one will be Trump, and his message is, I am pro crypto, but more importantly, I am unkillable. All right, transact. Cool. So you've added one candidate. Now let's add Biden, and then his message will be, I am not really pro crypto, but TBH, I don't understand it either. All right. Cool. So now we've successfully added the 2 candidates. So let's check our candidate count. It is in fact 2. And if we go to candidates and we put the ID of 1, we get Trump and his message, and his vote count is 0. And if we put the second one, we get Biden, his message, and his vote count is 0. Okay, perfect. So it's working as intended. So why don't we go ahead and actually vote for a candidate? So we'll start off with this account here. So we'll vote for Trump. Okay, successfully voted. Then if we call candidate of 1, we'll see the vote count has incremented by 1. Then let's change to the next account and vote Trump again. And then vote for Biden on another account. Vote 2. Okay, cool. So now our Trump should be 2 and Biden is 1. Now why don't we go ahead and, why don't we actually try vote again from the same account. So we'll change the account to the first one. We will vote for Trump again. And there you'll see it didn't go through. So it says there's an error message, and the message is SOS, you can only vote 1 time. All right, so that works as intended. So why don't we go ahead and call the getWinner function. So it says the winner is Trump and his total votes are true. So that is correct. Now, why don't we go ahead and actually put Biden in the lead and see that it changed. So vote for 2. That went through. Change again. And vote for 2. And then getWinner. And the winner is now Biden with a total votes of 3. All right, guys, and that is how you create a smart contract of a decentralized voting system. If you got any value from this video, please subscribe to the channel so that YouTube can also recommend more videos like this.